Hello everyone, this is Brad Tallis from Autodesk. I wanted to welcome you to another Fusion 360 Live. We're doing a CAD Hangout with one of our customers, Blaise Barrette. Actually, he's that way. So Blaise, welcome. So really quick for everybody, you'll notice, you might recognize Blaise, attends quite a few of our live streams and has been helping out the community quite a bit. And I saw some of the stuff that he's been working on with Fusion 360, and I'm like, I gotta get this guy onto one of these live streams. And so what this is basically going to be is a show and tell. Blaise is going to show off some of the amazing stuff he's been doing with Fusion. I'm blown away. I hope you all will be blown away with what he's been doing. So Blaise, why don't you introduce yourself, kind of give us a quick, who are you, what's your background, and then we'll dive right in, okay?
Well, first of all, thank you so much for having me. It's an amazing honor, really, for me to be here. I've watched every single one of your lives, so to be here is wow. Yeah, I'm from Quebec, Canada. My first language is French, and my English might be a bit rusty, so Brad, you'll help me if I'm looking for words. Yeah, I'm not an engineer and nothing like that. My work was primarily a web programmer, web developer. So I know a bit about programming. But I've always been pretty good at making stuff. And well, I'll tell you how I found Fusion is I built my own CNC a couple of years back, about 5 years ago, 6 years ago. And I built it, and then I didn't know how to use it. I had no idea how to make G-code so I looked online to find software that could generate G-code and help me, and this is how I found Fusion. And since then, I mean, it's just expanded so much, all the things that I can do. I've discovered the digital way of making stuff, and it's literally changed my life.
Yeah, that's actually the CNC that you're talking about is what piqued my interest, because I actually have done the same thing. I built my own CNC machine in the garage, and
Right.
when you showed what you were doing with it, not only that you built you used Fusion to help build it, but now you're building parts with it with Fusion. I wanted to see more about that. So if you don't mind, Blaise, I think everybody wants to kind of see what you've been working on. If you don't mind sharing your screen and kind of showing off and talking about
Yeah.
how you designed it, how you used Fusion, all that kind of stuff, and I'll probably sit back and be blown
I've
away.
I've done hundreds of projects in the last maybe 6 years or so with Fusion, and I picked projects that will I think will show a bit how versatile software Fusion is. So and we'll start. I'll start by sharing. I'll share my screen right away. There we go. Can you see my screen?
Yep.
Yeah, you can see it. Okay, so this is a do-it-yourself CNC. I am currently designing. This is not the CNC I have right now. The CNC I have right now has some pretty bad design flaws. It was not designed with Fusion because I didn't know Fusion at the time, and I gathered parts over the years, and I have all the parts to make this new CNC. So this is a project I'm working on. Will be my next CNC. To give you a sense of scale, this is a 4x8 area here, and it will have a tool changer, 10 tools in the carousel, which will be fixed to the gantry, and it'll pivot in and out. But before I wanted to start the mechanical side of the CNC, I wanted to work on the electronics side of it, make sure that I can get all the electronics right before moving on to the mechanical side of it. And one big part of this is the control panel. So I'm going to move on to the next project. I have a lot to show, so it'll be it'll be a bit of a marathon. Okay, so this is like my bench control panel, just to test things out.
Wow.
And it has all of the main controls that you would want to have on a CNC. Oh no, my trackpad just lost connection. Fortunately, I have a mouse. Okay, so this is the control panel I've been working on, and it's working great actually. And making this in the process of making this control panel, Fusion Electronics just came out pretty much at the same time, and I thought that was the perfect project to get acquainted with Fusion Electronics. So I designed this PCB here. Actually, I'll just stop the sharing for a second.
Wow.
And I can't see myself right now.
No, you're fine. We can see. Yep.
Just a second. So, okay, good. Right. So I designed this PCB here. And this is actually an ESP32. It's sort of kind of an Arduino, but a bit more powerful. I've discovered these maybe a year back, and I've been using them a lot. So I had this PCB made. Okay, back to screen sharing.
So you used Fusion's ECAD capabilities to actually create that board, and then you had that board manufactured.
That's right. That's right. And I mean, it took about a week to get here from the moment I ordered it. So it's super fast, very impressive, and the quality is great. But still, I'll show you some. Okay, just quickly, I've drawn these wires. That's because I want to. I'm in the process of making an Instructables. So I needed the nice render, so that's why I drew all these wires. You can see
amazing.
Yeah. And this here is the actual control panel on my bench test. You can see the servo motor, the drive, and the control and everything. The power supply. It's all. It looks very messy, but it's working, which is what I want to know.
I'll bet you
Anyway,
everybody watching is geeking out just looking at your workshop and stuff like that. So, a couple quick questions for you. So, you have a cool little display. Is that just like a decal? Is that how you did that for
oh
the?
yeah, yeah. But it's a decal of the real actual information that I have on my LCD. So it's pretty much it's how it looks in real life. You have your DROs here and the jog status and feed rate override, spindle
Cool.
speed override, and so on. Yeah. Okay, so as I was saying, I'm pretty new to electronics, and this was my first PCB actually. And I mean, Fusion, it just blew my mind how easy it was. Of course, I've watched all the Edwin's and Jorge's live streams and quick tips and so on, which made it very easy for me. So I designed this first PCB, but even a week for me, I like to I like to be able to make stuff myself, and I looked around on the net to find if there was a solution to make PCBs, engrave PCBs, like a small CNC machine. And I found this CNC project on GitHub, which is called Cyclone PCB Factory, which is a very small CNC. I can show it to you right here. Can you see it?
Yep.
Yeah. Okay. So I modified it quite a lot. The table was like you could only engrave a single size of PCB, so I made it so that it could accommodate any type of any size PCB. And I made like tool holder and this little control panel and a place to tuck away the power cord and stuff like that. But the thing which is most interesting about this project is that I created the controller for the CNC with that CNC. So I had all the parts on a breadboard, and while it was on a breadboard for testing, I engraved the PCB that would make the controller for that same
Machines making machines. That's pretty cool. So
yeah.
So you had like all the wires running to the CNC machine off of a breadboard, and so it was actually running, and you were sending G code to it, and it was actually drilling the holes and etching the.
That's
board.
right. That's right.
That's incredible.
I can show you here the controller. Just a quick video of what it looked like once.
So that machine cut those traces on that board. Wow.
Right.
Yep.
Right.
There's the stepper drivers. Those three heatsink things are the stepper drivers. Yeah.
There. Yep. I have this little video. Some of you might have seen it on the Facebook group Fusion 360 users. I'll just play it now. Just put the volume down a bit. No, that's not the one. This one here.
Oh, cool. Yep, looks just like it. Cool, fly through. That's the actual machine. Wow. Now I want one of these. That's really cool. Huh.
Pretty cool, right?
Yeah, and I've noticed you actually added, looks like you added like slider joints and motion and all that kind of stuff, so the machine would work in CAD just like it does in real life, which is pretty neat. So
yeah, that's right.
So So Blaise, I got a question from Peter Stimple. He was actually asking, how did you create the cables on the controller board? How did you create those cables to look realistic like you did?
Well, you'd have to watch one of Brad's live. I just I followed Brad's instructions to the letter. It went perfectly. Yeah.
Yeah, so we don't have cable routing per se, but you can create splines, and now that we've added that 3D spline functionality, it makes it even easier. In fact, I probably should
Yeah.
do an updated version of that. But yeah, so Peter, that's how he went about doing that. Is just basically routing splines and then doing a sweep along those splines. So
Yeah.
great question. Thank you for asking that, Peter.
Yeah, great question. Okay, moving on. I'd like to show you quickly. We'll move into the electronic side of things. I'll show you the. Why is it not moving? Okay, there we go. So we are now in the electronics environment of Fusion, and this is the control panel for that CNC. My mouse is not responding so well. Okay. Oh no.
I think you closed it. Yeah.
Yeah, I closed it. I have trouble with my mouse. Oh, my trackpad is back. So sorry about that. Okay, so we the control is gone. I closed it, unfortunately, but still, of course, stuff like that has to happen in live streams.
No worries.
But that really doesn't matter because I thought I'd show my workflow from making a schematic all the way down to having the toolpath. It'll take about 7 minutes or so.
Okay.
Is that okay?
Oh yeah, absolutely. I think everybody would be interested in seeing how you did this. And the thing I love, go ahead and bring that up, and I'll sit here and talk for a little bit. The thing that I love about this is not only are you creating the parts for the CNC machine, the fact that you're actually creating the board and you're using Fusion for pretty much everything, including the renderings, including the cabling, including the ECAD.
That's right.
Generating the G code. I mean, all in one tool. That's what I think is just amazing. So.
Yeah, I absolutely agree. Okay, so now we're in the electronic environment. I just created a new schematic, and now I'm going to add parts. And for this, you'll have to watch Edwin's and Jorge's live streams, how to create libraries. I'm not going to show that, but that would take way too long. But I created this library, and in there I have boards like Arduinos and the ESP32. Like this is these here are the little stepper motor drivers. ESP32. I even have this LCD I use a lot in my projects. So let's load the ESP32. I'll put it here and then press escape, get the LCD, rotate it a couple of times. There you go. And now I'll just R on my keyboard and quickly do some routing. Ground, 5 volts. Oops. Okay. I'm a bit nervous. Okay. Now, these routing I'm doing right now, this is not how you would connect an LCD, this LCD to ESP32. It would not work, so don't try this at home. It's just for show purposes, okay? So now we have our schematic all ready. This is the simplest schematic we could do. We'll switch to the 2D PCB environment. I have my PCB here, and this is the LCD. I'll just drop in here. And you see that the LCD already makes its support holes, the mounting holes automatically, and it has these red area when auto routing, so that because the LCD has standoffs that are on the actual PCB, they're so I don't want it to rub against traces. So
these are
auto
like
routing will
keep
move
clear
around
areas or
the
something
area.
like that. Yeah.
That's right. And this is our ESP32. I'll just rotate it like that. And now they're both on the top side, which is not possible. So I'll just put the ESP32 on the bottom side of the board. There you go. Now we might try to redimension. I noticed probably because of the zoom, it's
a little slower, yeah, because we're pushing through Zoom and then into YouTube through OBS. Yeah, we're bringing down the internet.
Okay, so now this would be our 2D PCB. We're ready for routing, so I'll just hit the auto route button, and I want all of my traces on the top side of the LCD. So I'll just disable the bottom side, and we'll go effort high because why not? It's just so fast. So continue, start, and check this out. Boom.
Wow.
It's routed. But these traces are way too thin for my milling machine. They would break. So I need my traces to be way thicker. So what I did, I hope Edwin and Jorge are not like, oh my God, what's he doing? Because I don't really know what I'm doing, but so far it's been working for me. In the DRC rules, you have all these for a thickness of the traces and the vias and so on. You can set all that up in there. I've tuned it, tried different things, and you can save these settings. So I'm going to load this one here, select it, and now you've seen. I don't know if you've noticed, but the pads are already thicker. But I have to go back into design, rip up the actual traces so that we can reroute them again. And I'll just say continue, start, and check this out.
Wow.
Boom.
Yes.
And these traces I can mill with my machine. So now we're ready to switch to the 3D.
Well, and you can even see in that how it went around those keep out areas for those red areas.
Right.
Yeah, that's pretty cool. I've never seen that before.
Yeah, I know. Okay, it's loading right now. This is going to take a few seconds. A few seconds. What's a few seconds? I mean, to make something that cool.
Well, now it's taking that schematic and actually physically building the 3D PCB. That's right? Yeah.
That's right. It's slower than usual. I can really see that. Normally, it would already be. I hope it's not going to take too long.
Yeah.
But it's working. It's working.
Yeah. Yeah, and you heard Blaise mentioned Edwin and Jorge. They have a live stream series also where they go through pretty much step by step, how to create a board, how to create traces, how to import libraries and stuff. If any of you are interested in the ECAD side of things, definitely look on our Fusion 360 Live YouTube channel for those live streams because they're incredible. Very, very, very smart guys. And I did a quick live stream, a 1 hour live stream. I basically regurgitated what they told me. So I highly recommend that. Okay, cool. We see the board now.
Yeah, we see the board, and you see the ESP32 is all in 3D. I mean, this is amazing. It's so fast, I'm just astounded by how fantastic this thing is. You can see here the traces moving around the standoffs of the LCD.
Yeah, and it even drilled the holes through the LED, the display board.
That's right.
Wow.
For the mounting of my LCD. And if I turn off the packages, the SP32 and the LCD, we can see the board. And I told you I wanted to take this all the way to making the toolpath. So we won't need these pads. I'll turn them off. We won't need the solder mask. If I open this, we can hide this little screen. So we're left with pretty much just what I would actually need to go to the toolpath. And check this out, Brad. I don't know if you knew that, but I'm in the 3D PCB environment, still in the PCB, and I can switch straight to manufacture right from here.
Wow. Yep.
I mean, this is mind-blowing. I'm going to create a new setup. This will take about a second or so. Here we go. I'll place my work offset right here. And now, okay, my model will be this body here. So model, the board itself, and the stock will be relative size with no additional stock. There you go. That's it for the setup. That's all we need. We'll need the copper traces, but still now we have to generate and create toolpath. I created a template for milling PCBs. So there you go. I have my toolpath. If I generate this, all my holes are picked already. And now this one here, there's a little work, but it's not that bad. We have to pick every traces and pads. But I mean, oops, cancel.
Yeah, and for those of you that you saw Blaise do it, he had a template, and I forgot to mention Angelo is helping us out today. He's on the keyboards and stuff like that. This is probably one of his favorite commands is templates, because if you're doing repetitive things over and over again, kind of like what Blaise is doing with circuit boards, you can have tools, you can have different kinds of tool paths created as templates, and then you can apply that to any part or any design, and it basically knows the feeds and speeds, the tools, the offsets, all that kind of stuff. So maybe in a future live stream, I'll bug Angelo to talk about that a little bit more in depth. So
yeah, okay, that's it. We have our tool path. We're ready to simulate. So I'll hit simulate here and press play, and there we go. Drilling all the holes, and I'll just skip the holes so we can see the tracing. So this is G code ready to send to to that little CNC I have.
This is so cool. I mean,
actually,
again,
I have the CNC with me right here.
To reiterate that, I mean, all in one tool, and you send it to that little guy, and he's cutting parts on your desk within a few minutes of coming up with the design, and you're not having to ship this out and have it, wait a week or 2 weeks or whatever it was, which actually isn't that long of a time, but the fact that you can do this yourself, I'm geeking out over this. That's really, really cool.
I know. Of course, there would be very simple PCBs, and I still have to tune some things, but still I get some pretty nice prototype PCBs already with this little machine, which has like a few hours turnaround. Awesome. Yeah. Okay, so now we've talked about the PCB. Now, this is CAM. This is manufacturing, and this is what I do for a living. I made my own CNC. I learned how to use CNCs, and there's a little shop in my hometown that work mainly aluminum, and I gave them my CV, and I got the job. I got this job because of Fusion, really, and I love my job. So what I do at work is I do mainly snowmobile parts and also side-by-side parts. I've got a few of them here. Maybe I should stop sharing my screen for a second. Can you start sharing the screen? I mean, okay. Can you see my screen now?
Yeah, but
I won't stop sharing the screen. Yep. Okay, now you see me?
Correct. Yeah.
Okay. here I am. Okay. I'm sorry. I'm new to Zoom, so.
You're doing
Okay.
awesome, Blaise. Trust me, I hope everybody else online is geeking out as much as I am. So this is really cool. Oh wow.
Okay, nice. Yeah, so all of these parts I machined at my job. These are like rear wheels for a snowmobile, and there are quite a few parts. This is an assembly, so this is a part. This one is a part as well. This, of course, is a part. This and this. These are all assembled. And the shaft part, I make two of them in one cycle. You know, when I press start, I get two full shaft assembly with a TM1P from Haas. Is one of their smaller models. So I had to be pretty inventive on how to accomplish that. This is not a 5-axis or anything like that. I'll show you some other parts. This is to start the snowmobile.
Wow. Jeez. And these are designed in Fusion?
Yeah, designed in Fusion, and I make 4, I think, of these each cycle.
Wow. I wish I could see Angelo's screen right now. He's probably geeking out too, seeing all these manufactured parts. So, oh wow.
This is a simpler part, but I managed to do it in 2 operations. I make, I think, 4 of them at a time, or yeah.
And it looks like there's like texture on the bottom side of it. How did you do that? Is that?
Oh, it's just an engraving tool.
Oh, okay. Cool.
Yep.
Man.
You can see the logo here.
Yeah.
This is more of an assembly. You have like anyway, you have some accessories that would hook here, and you can lock them. Okay. But I have some plastic parts and metal parts, and they're all. I try when I make an assembly to make every part of the assembly as much as possible in one cycle. And this here is the latest project I've been working on. These are for side by side. You see there are 2 different models. They have different inner diameters. This is 1.75. This is 2 inches. And just put that one back here. And again, this is an assembly. You see there are 2 parts. Let's say this is the base, and this would be the collet, I'd say. And it fits with these adapter plates, to which you would hook, let's say, like a chainsaw holder or fuel tank, the accessories. So you have these clamped to your side-by-side tubing, and you can place hook all sorts of accessories.
Cool.
And my boss gave me permission to show you the setup, how I make these. I make both parts in one cycle, finished parts. This one here has the base has 5 operation, and the collet has 3 operation in one cycle. So this is the next project I'll show you. I'll go back to screen sharing. Is this working?
Yes. Yep. We can see your screen.
Okay. Excellent. So this is the setup.
Oh, wow.
We call this a production plate. And you can see that this is the inner 1.75 inner diameter, and these are the 2 inches diameter. So with the same setup, I can make both product, and with the synchronized view cycling. I mean, this is. It's changed my workflow. It's so that the time I save just from moving from one setup to the other is just it's crazy. For me, it made a huge difference. In yellow, this is the stock. So we start with round stock like this. And maybe actually, I think I'll just make a simulation quickly so we have a better understanding of what's happening. This will take about a minute or so. Okay, here we go. So in blue, this is material we still have to remove. In green means that these surfaces are finished. So if I press play, maybe accelerate it a bit. So now we're with the same tool. I pick a tool and I try to do as much as possible with that first tool and then switch to the next tool. So it's doing all operations, first, third, not necessarily in order, just what's most convenient. Now we're doing some 3D with a ball mill.
Yeah,
Can you see that, right?
This is really cool because you're kind of talking about doing it in one cycle or whatever. So instead of like you could have a 5-axis machine and it would kind of be able to get into all those areas, but with your machine you're kind of limited to what you can do. But you're
That's
able
right.
to you're able to position these parts so they can get machined on all different sides. And I love I'm assuming you modeled that table with all the hold downs and everything like that.
Yeah, yeah.
And that's what you're registering off of when you load the parts, and then.
Yeah, my actual XY. I'll show that later. There's something first I'd like to show here is one toolpath I'm pretty proud of. There's this chamfer underneath this part, and I have to get it right here. So I modeled this tool here with the form tool. It's over here, form mill. This is a lollipop mill. And check this out. I'm quite proud of this. So at the beginning, it's working with the bottom half of the sphere. And as it goes up, it's doing the chamfer with the top half of the sphere.
Wow.
In one swift move.
That is pretty cool. Thinking outside the box. What tool would you use? That's pretty neat.
Yeah, that's right. And I'll show you quickly how I made this toolpath because it's not that obvious. Okay, now we can see here my X, Y, and Z. I pick this hole for my X, so I can take off this whole production plate, put a new one for, let's say, making wheels or other product, and I just come down with a probe in that hole and touch the walls of the hole, and this automatically sets my work coordinates in the machine.
Cool.
This is from that hole. Everything else is indexed. Yeah, and you can see here inside of my setups, I have my 2 inches, my 1.75. I put all of my my operations in folders by operation. So let's say I'm looking for any operation in the first up, then I just click on the up one folders, and I can very quickly find the tool path I want to work on or modify or whatever. So this is pretty neat. And the NC programs that came out, Angelo could verify for me, but it's about maybe a year ago or 6 months ago, something like that. And this, speeds up my work so much. You can see here that I have all my setups for like all the 2 inches or the 1.75. And the fact that I'm organizing by operations in there, if I want for, say, just to machine the first up, I have a NC program for that, and it's just so fast because all I have to do is check the first all the folders for up one, and I'm good to go.
Yeah.
So it's super fast.
The NC programs definitely do speed things up. So
Yeah, very efficient.
yeah.
Okay, quickly, I'd like to show. Oh, there's a. While we're still in the cam environment, I'd like to show these here. I've came up with this solution for the first time with this project. I made these sort of tiny soft jaws, if you will. These are pitbull clam, mighty bite pitbull clams. When you tighten the screw here, they put pressure, and they hold your part with a lot of pressure, actually. And this surface, I didn't want it to be marked or damaged in any way, so I made these tiny soft jaws that hinge on this thinner material here. And the hinge doesn't really fatigue because, as soon as you put pressure here, it's already, it's not really moving. So there's no fatigue, and it's been holding very well so far.
Wow.
Yeah, I didn't have any parts flying or anything bad happen so far. And you see these big gouges here. I'll show you why they're there. It's pretty cool, I think. It's this toolpath here, simulate. There we go. This is a T-slot mill, I mean. And these gouges are just so that the mill could go down here and in a way apart and come out again.
So those little pads are actually part of the table. They're not screwed on or anything.
No, that's right.
That's cool. That's a cool thing.
Yeah, I think so. It worked out so far. Huh. Okay, now just quickly, we have to move on because there's so much to look at.
Yeah, we could talk for hours, I'm afraid.
Sorry?
We could probably talk for hours, Blaise. I mean...
Yeah, I know. Well, you let me know when when that's enough. Okay, so I made these sketches. I have I'll put it like this. These circles actually are the same, are the exact diameter of my lollipop mill. Okay, and I projected these two edges with an intersect project. Project intersect, yeah, and made these lines from these projected points all the way to the center of the circle, and then I lofted the triangle part.
Okay.
You see that? And this here, this edge, can you see it?
Yep.
This edge here is the tracing, is what I picked up for my tracing operation to do the chamfer.
So that's what your tool actually follows.
Yeah.
The center of it is on that line, and then it's going to cut that edge. Now, could you not have used just a regular chamfer command, or do you have to do...
No, I had to, with form mills, there are some tool paths you cannot use. Okay. I wouldn't be able to enumerate every one of them, but yeah. So no, I had to come up with, I've been using a technique like that quite a lot with the trace operation to have the tool exactly go where I want it. When it's there's just no other way.
That's really cool.
Okay, so I think that's pretty. Oh well, I could show you like pictures of the table, the actual CNC. You can see here the round stock. This is before I push on the start before I start the cycle, and this is after the cycle. So you see that the first half has been machined here. I can flip this one. So at the end of the cycle, this part here and this part here are finished. They're ready. There's nothing else to do other than powder coat them and put them in a box to send to clients. So these two parts are finished. So I pull them out. Then I flip this one here, pull this one here. Can you see my cursor?
Yes. Yep.
Okay. And then I'll take this one, put it there. Take this one, put it there. And at the end, I have like these two places empty so that I can put some more round stock and push cycle start again.
That's
So
cool process. That's really neat.
yeah, you can see it working here. Okay, that'll do.
Okay.
Oh, and here's just quickly these little soft jaws. Okay, so I think can you see me?
Yep.
Okay. So at the beginning, I said I was going to show very different type of projects. So we've seen now machining. Now I'd like to show something completely different that I used Fusion for. So back to screen sharing. This is a deck I made for my father. And fun fact about my father is an actor, and he he played in the movie. If there are any hockey fans there, you might have seen the movie Slapshot. It's an old movie with Paul Newman. Well, my father is the goalie of the
That's cool.
of the Chiefs. Yeah, and he was in Australia signing autographs when I was working on his deck, and that's why I drew the whole house so that he had a better understanding of what it would look like. So that's why I drew the house like pretty quickly, but still. Now, if I hide the house, we can see the whole deck here. So this was drawn with Fusion maybe about 3 years ago, and yeah, and one interesting thing about this project is that well, at the time I'm looking for the word, a derived operation. They weren't out yet. So my workflow at this time was to have all my CNC toolpaths in the same project. So, if I highlight all of my, you can see all the setups just as they are in the project, all the handrails and the stairs. And so if I get this out, you can see the toolpaths in there. So I would do all that, have all my parts ready in my home shop, and then move to my father's. I'll take all of the parts already machined and CNC'd, and even all these little.
Wow. Yep. Railings
were made on the CNC. Yeah. So I would get there and just assemble the whole thing. Everything was already cut to length and everything. I have some pictures of the real deck here, and this is the render.
I love this. Is one of my favorite pictures where they match almost exactly the same. I think that's way cool. And for all of you online, this is pretty cool that he did it this way, because he knows exactly how many pieces of wood he needs to buy. You're not buying extra, or you have to go back to the store because you're 4 boards short or whatever. And I've shown in one of my live streams, like we did the bathroom, I knew exactly how many pieces of tile I need. I knew how many cuts I'd have to make, all that kind of stuff. And the fact that Blaise was able to model up the designs for his dad, his client, right? They were able to see what it was going to look like even before they bought a single piece of wood. I think that's pretty amazing.
Actually, the next project, it shows that again pretty much, because this is a turntable I made for a client. It's a turntable for photogrammetry, to like you put an object on it and it turns so many degrees and take a picture. And at the end you can assemble this and make a 3D object out of it. And yeah, again, I could show that to my client, so there's no surprise. They know exactly what they're going to get. And even one of the thing they wanted the turntable to be able to hold a 20 kilo object on it. and I could even simulate. I would put a 20 kilo, force here, and know that I could tell my client that if you put the 20 kilos on the edge, you'd have like less than half a millimeter deflection.
Oh wow.
It's reassuring for the client. He knows that what he's gonna get is it's gonna work. I can show quickly the insides. You can see the stepper motor, and at my shop where I work, we have a water jet cutting machine. So all the parts were water jet cut. And what's the word for that machine that plies
a brake, sheet metal brake?
Yeah, I think so. Yeah, so we also have that. So we could have all the parts, all the sheet metal ready at work. And yeah, you can see it.
Wow.
And oh yeah, sure. Just quickly, we have the electronics. Fusion Electronics wasn't out then. This is over a year ago, that project. So, but it's unfortunate. It would have been real nice to have a Fusion Electronic back then. Yeah, and the thing I'm most proud of about this project is that there's no welding at all. It's all assembled. So once I got my parts, I could assemble this, easily in a few hours. If I turn on the color cycling, you can see that these support are sort of jointed, we could say, and when you tighten that screw, it's pulling on that bolt, which is putting pressure, so nothing moves, and you can see that it's all assembled that way. So if the client wants to maybe have a larger turntable, we could just very easily just water cut another one and just put it there. Since nothing is welded, it can be easily undone and modified, or because this is pretty much, it's a one-time thing, and so we're not going to make 500 of those, so it will always be a prototype, if I can say that way. So it's interesting when you can disassemble and modify it if something goes wrong, or I don't know. So but so far it's been working great. The electronics, like you can program, let's say you want 36 pictures, so you program it, push the button, and then the table would turn 10 degrees, and an infrared LED would send a signal to the camera to take a picture.
Wow. That's really cool. For everybody that's watching, if you have any questions for Blaise, go ahead and put them in the chat. Angelo's monitoring the chat and answering lots of questions. But if you want a particular question for Blaise, feel free to throw it out there, and we'll see if we can if we have time to answer some of those for you. Because stuff like this, I think, is incredible, and it really highlights the power of CAD, where you've modeled this whole thing, things are going to fit, how many pieces, how much material you're going to need.
Simulation.
Now we have ECAD, now we have a range, where I showed that last week, where you could take all these sheet metal parts and lay them out, and it'll arrange them, to minimize waste, etc. But the fact that, you have all the hardware in here, you're going to have an accurate bills of material, your drawings, everything, and that everything's going to work and fit together before you actually cut any material. And that's
right. I used the McMaster-Carr insert tool extensively on this project. So at the end, I had my bill of material, send this to a McMaster-Carr, and just when I got the box, I just assembled the whole thing. No surprises. Yeah, crazy. And this takes us into robotics. I am a mentor in a first robotic team. This is an international competition. I think there's like over 6,000 teams around the world. It's if you're good at making stuff and you like spending time with kids. You check this out. It'll change your life. It surely changed mine. I've been a mentor for 5 years. I've been teaching Fusion 360 to my teammates. I had a class with like 20 students, and I did it. The last 3 years. The last year, of course, was canceled because of the pandemic, but otherwise, I taught Fusion to a class, and I made these videos on YouTube on the Teams video channel. I think it's in the description.
Yep.
Yeah, but they're in French. There are tutorials. There's 10 tutorials. You can check them out if you speak French. The competition, you have a new challenge every year, and you have to design, build a robot, and you have 6 weeks only to do that. It's a lot of work, but a lot of fun, and I'll show you the last 3 robots we've designed. How are we in time?
Oh, we're fine. Don't
we're
worry.
fine. Okay.
Yeah.
Okay, excellent.
We'll probably I mean, it's about 6 minutes to the top of the hour, but we usually go over on my live streams anyway, so nobody will be shocked.
So. All right. So this robot we did in 2017. I'll show you a quick video of what it looks like. The first, I'll take the volume down a bit. The first 15 seconds is autonomous mode. So right now the driver is not driving the robot. The robot is doing its stuff by itself. And now the driver just took command of the robot. We have to go all the way at the other end of the field and pick up these big plastic gears. There you go. And then we have to place these gears on hooks. And you see the turret there has vision, so it always tracks the. And at the end of the game, we are climbing up a rope. So this is the.
Holy cow! So you had to make the robot climb a rope.
Yeah,
that's amazing.
So quickly, you can see here the turret. There's a Raspberry Pi in there with the Raspberry Pi camera. This is the flywheel that throws the balls into a basket with ballistics. So it was a pretty hard challenge, really. These are like the sort of the basket jaws that hold the gear, so the gear would fall in there and finds its place. This would pick up the yellow balls on the terrain and pull them in. And this is what we use to climb up the rope at the end. And it uses mechanism wheels so that it can move sideways and so on. 6 weeks to build that and practice. And now the next robot is really my personal favorite. I love that robot. This whole thing here can move up and down the rails here, and it can pivot 180 degrees. And the clamp can with this hair, is that piston the name in the word in English?
Yes, piston. Yeah.
That air piston would push the whole arm assembly out for an additional foot. And of course, these clamp would open and close. And even at the end, it would use these hooks to lift itself up at the end of the game, which would, give some more points. And what the robot has to do is pick up milk crates and put them in scales. And if you have the scales tilting your way, then you make the points. And I'll show you. I'll show you a video of the autonomous mode. We were practicing the autonomous mode. This is my son, by the way. You can see in the background.
Oh, wow.
No, wait. First try!
I'm going to have to show my son this. He did First Robotics last year, but yeah, so similar challenges. They have to pick up certain colored balls and put them way up high into a tube
All right.
and all this kind of stuff. He'll enjoy this one.
How cool is that robot?
Yeah.
Really. It was really fun to watch, and we had a lot of success with it too. This is the last robot I'll show you today. This robot was the smallest, the most compact we ever did. I think it'll be easier to explain if you see the video first. This is our pilot practicing. It had to pick up and place these discs, and you see that the disc is turning. This is just for show. The disc is turning, but it has no purpose. It's just for it's just for show. And you can see how compliant it is. That compliance is actually not that easy to make. It was quite a challenge, really. But we so that the robot doesn't have to be perfectly centered on the disc. You know, it could be a bit sideways and the thing would just grab the disc anyway. So yeah, this is where most of the work was done. These would slide on these rails, and these are polycarbonate, which is, you know, it can take quite a beating. So these would flex. If you put pressure on this side of we'll call it the head or the end effector. If you push on this side, these would flex and this would move back, while this one might just not stay there. They have constant force springs that pull them always to the front of the robot. And these parts here would, you know, they have this spring, so when the disc comes in, it pushes this one can move in, and so that passively, you know, the pilot, all the pilot had to do is just like throw himself at the disc and it would grab it.
Wow.
And when you want to release it, this little motor would pull on this part, so that the bolt here would push this thing. The hooks would come in and the disc would be able to come out. And you can see here all the limit switches to know the position of the part and so on. And these two little limit switches send a signal to this servo motor that would pull that spindle up, which made the disc turn.
Yeah.
No other purpose than just being cool.
So Blaise, I did have a couple questions come in. So, so Peter actually asked, can Blaise do a future live stream on the robotic building? Like, how did you go about, you know, designing and building these robots? Which I think is such a great idea. I'm not going to put you on the spot, but you know, I know fusion is used quite a bit in some of the fighting robots that you see on the Discovery Channel and stuff like that. I've actually worked with a team here in Loveland where they used fusion and had one of the robots. So maybe I could see if I could get them to talk too. So Vital asked a question: how long did it take you to model that turntable, the photogrammetry turntable?
Oh, right. Well, it's been over a year ago, so I don't really remember, but maybe, I don't know, the most of it would have been drawn within maybe a day or a few hours or something, and really to go into the details and everything, 3-4 days, something like that. I don't know.
That's pretty cool. And these robots also, I mean, really, again, reiterate what I just said earlier, where you know that all the parts are going to fit. I know, for example, in First Robotics, some of the robots have to be a certain size. They can't be too large. And the only reason I know that is my son's robot got disqualified because it was one nut too wide. It didn't fit, you know, because they had a bolt sticking out or a nut sticking out too far.
Right.
So the fact that you can visualize everything is amazing.
Yeah, you even have weight limits. Yep. Like it has to be below 120 pounds or something like that. So you can actually get the properties of each one of your parts and know beforehand pretty much how much you're your robot is going to weigh if you think you might be close to the limit.
Right.
Yeah. Maybe the last project I will show today is also work I've done with my robotics team. It's a swerve wheel we're working on. This is this I'm pretty proud of. One thing I'd like to say before going further, I'm not drawing this back home by myself. I have kids with me, and I tell them, okay, maybe you could draw this part or work on this, and so the kids that I've been showing Fusion are now really good at using Fusion. So I'm not alone. So this is really a team effort. So this is a swerve wheel. Swerve wheels can rotate indefinitely this way. There's a slip ring here so that the wires keep their connection, even though this can turn indefinitely. Yeah. This is the motor that actuates this pulley here, and maybe I could show the analysis. Okay, here you have the center of mass, which has to be pretty much centered. So we had this, there's a lot to think about when you when you make something like this. So we managed to balance the parts so that the center of mass would be pretty much in the center. And if I show a section analysis, I'll just edit this and hide the hatching. I think we can see better. Yeah, so the actual motor that makes the wheel itself move is inside the wheel. That is the motor here. And you can see it's pretty jam-packed. There's a bearing here and a bearing here and all the parts. And so the motor would actuate these pulleys, which have a shaft going all the way on the other side, and these would actuate this larger pulley, which is attached to the wheel. So this is how the wheel is turning, and we have all of our gearing down and stuff. Yeah, so this is this is the last project. I just realized that there was another tutorial I wanted to put in there, and I just forgot. So maybe next time.
Well, so Blaise, to kind of wrap things up here, I've got some observations. So this is for everybody listening in. Notice how organized Blaise's naming. Every part has a name. The power transmission assembly, the main bearing retainer, etc. Please name your parts, name your assemblies, organize things, and you can see you can create incredibly complex assemblies that work and rotate together. If you take the time to organize things and name things, and that's one of the things I've noticed with almost every single one of your things you've shown today is just everything is organized and everything has a name. So awesome job on that.
Yeah, it has to be, yeah. Yep. Especially when you're working with a team. I can't wait to try that workflow with the edit in place.
Yeah.
Next on the next robot, we'll be using this extensively. We didn't have that on the last robots, so it does get a bit messy because there is a whole team and like secondary high school kids that help, so it can get a bit disorganized. But still, we try to keep it organized with the robots and the browser, because otherwise it just gets very messy and it's hard to find the parts.
Yeah. And then I also noticed, you're using the tools that you have. For example, McMaster Car, bringing in, nuts and bolts and washers and electrical components and etc. I love your wire routing through the plastic tubes, and you can actually see the wires. I think that's really kind of cool. But then
I don't do that all the time, but this is just like to have a cool render.
Right.
it's worth it. Yeah.
Well, and then even just the colorization of your models, you can kind of see what is what just by colorizing. Instead of everything in some plain gray, the fact that you kind of anodized each of these parts and stuff. Other
That's
thing
right.
I want to say is thank you so much for helping out with the first robotics. I also teach Fusion to high school students and also teach robotics. I really appreciate you doing that, and you're helping the future engineers learn the tools that they have access to, and then get to do some pretty cool things. So it's a thumbs up for that. I really do appreciate you doing that. So I don't see any more questions that came through. I know I'm going to rewatch this one because I'm just blown away with all the stuff that Blaise has been doing. The reason I wanted him to show off his stuff is so you can kind of see, when I do a live stream, I create a bracket or a flagpole mount or whatever. And here you're actually seeing Fusion being used for actual products. The fact that he made a CNC machine that made parts for its own CNC machine. I think that's really cool. The ECAD, the fact that Blaise is making his own circuit boards and all kind of stuff. You can make anything with Fusion. So
that's right.
Blaise, thank you so much. We're just a little bit over, so I kind of want to wrap this up. If there's anything you want to say.
Well, again, it's been really an honor that you invited me, and I'm really happy that I could show my stuff, being on this side of the live stream for the first time.
Yeah, and with that said, in the description of this live stream in the YouTube video, there's a lot of links that Blaise provided that show his first robotics team, his Instagram page, etc. I think there's a blog Autodesk did on Blaise a couple weeks ago. Really cool write-up. So yeah, I highly recommend taking a look at that. Again, Blaise, thank you so much. Angelo, thanks for helping out on the keyboard.
Angelo.
And we will see you on our next live stream. Thank you.
Thank you so much.
We'll see you.
Bye, everyone.
Okay. That was awesome.